welcome to my channel. This is Good Tutor, and what I do is solve technical drawing problems and also provide very important information that you can make use of for you to have better performance in your technical drawing examinations. If you're watching my video for the first time, I want to ask you to subscribe to this channel, put on notification bell so that whenever I upload a new video, you'll be notified, and help me to share my videos with your friends who are technical drawing students. And very important, you need to practice this subject. This is a very practical subject, so when you practice it, you surely master it. Now what I want to do now, I want to solve this problem question 29 on engineering drawing 1 written by Pick Up and Packer. Okay, this is question 29, so I want to solve it, and we have the instruction or the question written on this page. So I'm going to read the question, then we go back to that diagram. So here we have in the figure, the crank AB rotates clockwise about A, and the crank CD rotates anti-clockwise about C. The cranks are joined by the link BDF. Plot to a scale of 1 millimeter to 1 centimeter the loci of point E and F for one complete revolution of AB. AB and DC are 45 centimeters. BD is 120 centimeters, and BE and DF are 30 centimeters. So the scale given to us is 1 millimeter to 1 centimeter, so which I believe you know how to do, though I'm going to explain that. Okay, now these are the cranks. So we have this crank AB and we have crank CD. Okay, so point E is here and point F is at this point here. So distance between the center lines of these two cranks, that is the circles, so we have it to be 120 centimeters. So 120 centimeters, if you convert it to millimeter, as we are given the scale, that the scale is 1 millimeter to 1 centimeter. So 120 centimeters will give us 120 millimeters. Will give us 120 millimeters, and the radius of the circle for the crank AB is given as 45 centimeters. That means we'll be using 45 millimeters for that. Likewise, that of CD, 45 millimeters, and distance BE and DF, they said it is 30 centimeters. That means we'll be using 30 millimeters for that. So let's see what we are going to do. And do not forget that this crank is rotating clockwise, is going in this direction. So this is point B on it. Very, very important. And this crank also is the crank, this crank CD is going anti-clockwise, and the distance, that is the radius from here to here, CD is also 30 centimeters. We should be using 30 millimeters for that. So let's see what we are to do here and the shape that we are going to generate for the locus of point E and point F. Okay, so the first thing that we are going to do here is to draw a horizontal center line like this. Okay, now, so having done this, the next thing that I'm going to do is that I will set a point here. All right, then I will take a measurement of 120 millimeters. 120 millimeters. So this is 120 here, and I'll also draw a vertical line, a vertical center line. Okay, now having done this, the next thing that I'm going to do is to draw the circles. So I will take, so this is as we are given in the question, so this is center B, sorry, center A, so this is center C. Okay, so I will take a measurement of 30 millimeters. This is 30. Okay, then I will draw a circle. Sorry, the radius of the circle is 45 millimeters, not 30. It is distance BE and DF that is 30 millimeters. So I'm taking 45, not 30, sorry. Okay, so I'll put at point A here and I will draw a circle like this. Okay, all right, so I will also put it at point C here. I'll also draw a circle like this. Okay, so I've drawn the circles. I want to make this to be more feasible. Okay, so I've drawn the circles, so I'm going to divide the circles into 12 equal parts. I divide the circle into 12 equal parts, so I'm going to, okay, use my set square. So alright, we're dividing the circle into 12 equal parts as I said. So also here, alright, so we divide the circles into 12 equal parts. So I'm going to number. So looking at what we have on this diagram, so we have point B at this point. So very important. So B will be here. So put B here. This is B, and I'll put 0 here. So this is going clockwise. So this will be 1. This point will be 2. This point is 3. This is 4. This is 5. This is 6. This is 7, and this is 8. So where we have 9, this is 10, and this is 11. And for this one, so we have point D at this point. So this is D, and I'll call this 0. So this is going anti-clockwise. This is 1. This is 2. This is 3. This is 4. This is 5, 6, 7, 8. So this is 9, this is 10, this is 11. So very important. Alright, the next thing that we are going to do, so we have it here that this connecting rod that we have here, so it starts from here and it is connected with D, and it goes out a bit, and then we have point E here, we have point F here. So what I will just do is to join BD together. I'll join BD together like this. It go like this. It goes out a little bit. Alright, so I'll take a measurement of 30 millimeters. I'll take a measurement of 30 millimeters here. So for the first point, that is point E, 30 millimeters here. And I'll come here from D. I will take 30 millimeters forward. Okay, so this is point F, and this point here is point E. So we continue like this. So the next is we have what? We have 1 to 1. I will connect 1 and 1 together. So 1 and 1 go like this. So here I will take a measurement of 30 millimeters, and from 1 here I'll take 30 millimeters forward. This is 30. Okay, so we have this point, and then we have this point. So next is I will join 2 and 2 together, 2 and 2. So 2 on this and 2 here. I join them together. So I will take 30 millimeters forward from this point 2 here. So this is 30, and then from to here I will take 30 millimeters. This is true, so 30 millimeters. Okay, so we have this point, I will have this point, so I will do this one. So next we have what? We have 3. So we join 3 together. Okay, so I will take a measurement of 30 from here. So 30 from here, this is 30, and I'll come here and take 30 millimeters. So this is 30. So here we have another point, and here we have another point. So that is how I will continue. I will join 4 and 4 together and be taking the measurement as I've shown here. So I'm going to pause the video, and then I will do the rest, locate the rest of the point, then I will come back and show you the next thing that we have to do. Right, as you can see here, all the points have been obtained. We have located all the points. So the next thing that we are going to do, so we are going to join the point together with the use of a French curve. So I'm going to start with this. So I'm going to start with this. So okay. We need to take it easy so that we can get a smooth curve. Okay. All right, so all right. Okay, so last part for this. All right, so that's what we have there. So for this part now, for this part, so just need to adjust the French curve. Okay. All right. Okay. So adjusting the French curve is very, very important. You can get a smooth curve. You can see the way I'm doing it. So it's simple. So it's not something hard. Okay. All right, so the last part is this. All right, so these are the locus that we're asked to get. So we have that of point E, and this is that of point F. So as simple as I've shown it, all you need to do is to practice. When you practice, you surely master it. Thank you, and keep on practicing. God bless you. Okay, so